students, let's start the next video. It is about chemical energetics. It is one of the most important chapter of E1. So let's start. First of all, what is meant by the enthalpy change? But in this one, the first thing you need to understand is the exothermic reactions. Chemical reactions that transfer heat energy to the surrounding are described as exothermic reactions. And here I am giving few examples about it. Magnesium, when reacted with a sulfuric acid, there is a formation of magnesium sulfate, hydrogen, and energy will be released. The surrounding include the solvent, air around the test tube itself, anything dipping into the test tube. Now these are the different endothermic, exothermic reaction you can see here. Water and acid rain, campfire, rusting. Rusting is an exothermic reaction. Nuclear fission, it is an exothermic reaction. Freezing water, when we are going to freeze the water, actually the energy is released. So freezing water is an exothermic reaction, right? Other examples of exothermic reaction are the combustion of fuel, oxygen, carbohydrate in the bodies of animal, plants, and humans even. Reaction of water with the quicklime. Now move on to the endothermic reactions. Endothermic reactions are the reactions in which the heat energy from the surrounding is absorbed. So in endothermic reaction, temperature of the surrounding decrease. When sodium hydrogen carbonate react with aqueous solution of citric acid in a test tube, the temperature of the reaction mixture in the test tube decreases because the citric acid and the sodium hydrogen carbonate are absorbing the heat energy from the solvent, the test tube, and the air. These are the endothermic reaction: instant cold pack, cooking egg, photosynthesis. In case of photosynthesis, actually energy is absorbed from the sun, and that energy is used to make carbohydrates. So this is the endothermic reaction. Endothermic reactions are also includes this cold pack actually. So these cold pack may contain ammonium chloride react with water to make ammonium ions and chloride ions. So we use the cold pack to treat a spot injury. When you rub or press the pack, water and ammonium chloride in the crystal mix. As the crystal dissolve, energy is transferred from the surrounding, cooling the injury. Here we have the different questions in which you need to classify these as exothermic or the endothermic reactions. So before moving on to next, stop the video, answer these questions yourself. Enthalpy change and enthalpy profile diagrams. So basically delta H, this is known as the enthalpy change, and enthalpy change will always be equal to delta H products minus delta H reactants. It means that enthalpy of the products, enthalpy of the reactions. On the and the unit we use for this one is kilojoule per mole. We can draw reaction pathway diagrams, and the enthalpy of the reactants of products shown on the y-axis. The x-axis shows the reaction pathway with the reactants on the left and the products on the right. Reaction pathway diagram usually also show the activation energy E, a hump up and down the curve between the reactants and the products. The activation energy is the minimum energy that colliding particle must possess for the reaction to happen. It means that if there is no activation energy, the reaction cannot be started. Let's give you an example. When you are giving fire to any gas object, you need to start it with the help of a matchstick or any other way. So activation energy always have a positive value because enough energy has to be absorbed to increase the kinetic energy of the reacting molecule so that they collide with enough force to break bonds. Okay, exothermic reaction. This is the reaction pathway diagram. You can see here is exothermic one. These are the reactants. A very little activation energy is required and a lot of energy is released. And you can see here, this is the enthalpy of the reactant products, and the reactants are on the upper side, products on the lower side. This is the activation energy, this is energy released, and the delta H for this one is minus 890.3 kilojoule per mole. This is endothermic reaction. You can see the reactants are on the lower side and products on the upper side because the products have less energy, because we are given too much activation energy for this process. So it is 572 kilojoule per mole. This is the endothermic reaction in which we are actually breaking down the calcium carbonate to convert it into calcium oxide and carbon dioxide. So in the question you need to draw full reaction pathway diagram for activation energy for the combustion of sulfur and also to sulfur dioxide, and also the endothermic reactions H2O plus C equal to H2 plus C. So basically what you need to do is you need to draw these two profile diagrams, these two reaction pathway diagrams, this one for exothermic reaction, this one for endothermic reaction. So do it again, and when you do these questions, just compare them with these two diagrams. Right. Standard enthalpy change. Standard enthalpy, for the standard enthalpy change, first of all we need to have some standard enthalpy conditions. Pressure of 101 kPa, temperature of 298, and each substance involved in the reaction is its normal physical state. It means solid, liquid, or gas. The symbol, this symbol is used to indicate the enthalpy change. Refer to the reaction carried out under standard conditions. Like methane reacted with oxygen to make combination water with the release of delta H or the enthalpy change. This one. Right. A variety of the enthalpy changes. These are the variety of enthalpy change. Enthalpy change of formation, combustion, utilization, and reaction. Reaction is a general term actually. So the standard enthalpy change of reaction delta HR. The the standard enthalpy change of reaction is the enthalpy change when the amount of reactant shown in the stoichiometric equation led to give products under standard conditions. The reactant products must be in their standard state. The symbol for the standard enthalpy change of reaction is delta HR. Enthalpy of reaction can be exothermic or endothermic. The equation that describes the reaction must be given. This is the equation, right? And however, if we write this equation as this one, basically in this one we are, it is in the form of the molecular one. So actually, as it is for 2 moles, so the amount of the standard enthalpy change is double. Standard enthalpy change for the formation, you can see here iron reacted with oxygen to make iron oxide minus 82 824.2 kilojoule per mole, or the graphite reacted with sulfur to make carbon disulfide. This is endothermic reaction. So in this formation the energy absorbed is 98.7. Note that the state symbol for carbon is shown as graphite. This is because there are several forms of carbon, but the most stable is the graphite. We choose the most stable form when writing equations where enthalpy changes are shown. So this is known as the standard enthalpy change of formation. Enthalpy change of combustion delta Sc, in case of when sulfur going to burn to produce SO2 or methane going to produce carbon dioxide and water, both. In both of them you can see here the enthalpy change of combustion, the energy is released, it is not absorbed, so these are the exothermic reactions. Here we have the question, you need to actually identify all of them, right? And when you identify all of them, you need to write down that these are the delta HR, delta HF, or delta HC, right? Standard enthalpy change of neutralization. So whenever there is acid and alkali react together to make salt and water, always the energy is released, and this is known as the energy of neutralization. This is the ionic equation for this purpose. Now here we have the making the enthalpy change. How we can make the enthalpy change? For making the enthalpy change, we use this apparatus in which there is a water here, polystyrene cup, thermometer there, reaction mixture is there. Formula we use is the Q equal to mc delta T, where Q is the heat transfer in joules, m is the mass of water in grams, C is the specific heat capacity of water usually, delta T is the temperature change. So how we can measure it actually? The heat transfer for a known number of moles of reactant in a calorimeter is given by Q equal to mc delta T. So we then use a delta H equal to m minus mc delta T. A rising temperature given positive sign, so the value of delta H is negative for an exothermic reaction. A falling temperature is given a negative sign, so the value of delta H is positive for an endothermic reaction. Now these are different questions which you can calculate on the basis of the formula given here. This formula Q equal to mc delta T or delta H equal to m minus mc delta T. So do these questions yourself. I will make a separate video in which I will give you the answers to these questions, all these questions. That's it for the today's video, and and I will see you in the next video, in the next part of the energetics. There will be another part, so that's the part number 2. Thank you very much, see you next time.